Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 58 of Physics 5054. Today we are going to start the exercise of unit number 10, which is on page number 149. The first part, as you know, is multiple choice questions, and that is called section A. Four options are given. You have to select one of them, not two. So the first question is saying, when heat is supplied to a metallic sphere, which of the following changes will occur? The first option is the mass of the sphere increases. No. Mass always remains constant wherever you are. This is not the option, correct option. B, the volume of the sphere decreases. No, it is also not. C, the density of the sphere increases. No, it is also not. The internal energy of the sphere increases. Yes, we discuss these things in greater detail whenever you are supplying heat to a metallic body. It means that the internal energy of the sphere. So D is the correct option. I am writing in section A question number 1, and D is the correct option. Now let us turn our focus to question number 2. The specific heat capacity of a substance is the amount of heat required. Ladies and gentlemen, what you are saying? We discuss these things in greater detail. You must have to answer me in this regard. What is your answer? Yes, the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 Kelvin. And that is option number B. In 2 number question, option number B is the correct one. Now third number question, when a 0.24 kilogram, we are writing the data as we are facing it. So M is equal to 0.24 kilogram. And further, the question is saying a brass cylinder is heated using a 2 kilowatt. So power is equal to 2 kilowatt. You can write it 2000 watt as well, because the kilowatt is the bigger unit and watt is the standard unit. So we can calculate it like this. Okay, further, a temperature increase from 30 degrees Celsius to 100 degrees Celsius. So we have to write delta theta is equal to 100 degrees Celsius minus 30 degrees Celsius, which is equal to 70 degrees Celsius. So we are having this data and they are telling us what is the specific heat of the specific heat capacity of brass. So smaller c we have to find, and you know, as c is equal to 1 over m q divide by delta theta, and q can be written as p into t divide by delta theta, and that 1 over m will be, because we are given the data and t is also given here. T is given 3.2 seconds. They given us 3.2 seconds. So all the data is available and we can find C is equal to M, and that is 0.24. P is given as 2000 multiplied by 3.2, and delta theta is given as 70. So if we are calculating all these things, if we are calculating all these things, then we will get 380.89, 380.95 joule per kilogram per Kelvin. So it is nearly equal to 381 joule per kilogram per Kelvin. And in this case, the option number C is correct. C option is the correct option in this case. Now let us do question number 4. Question number 4 is saying a cup of coffee at 80 degrees Celsius is left to cool to 30 degrees Celsius. So it means that delta theta is 80 degrees Celsius minus 30 degrees Celsius, I think. Let us confirm it. Yes, 30 minus 30 degree Celsius, which is equal to 50 degrees Celsius. This is the first piece of information we are having. If the heat capacity of the cup and coffee is 2, not specific heat. C, capital C. If the heat capacity, it is not saying the specific heat capacity of the cup and coffee is 2 kilojoule, 2.0 kilojoule per Kelvin. Yes, from this we can also understand that this is the heat capacity per kilogram is not written inside this. So it means that we are dealing with the heat capacity and not the specific heat capacity. How much heat is released during the cooling? So heat we have to find. Now keeping in mind C is equal to Q divided by delta theta. We know that C is equal to Q divided by delta theta. And in delta theta, if we are putting the way, we can make the subject Q because we are finding the Q. So we will leave Q on one side and C into delta theta on another side, and that will be joule. So both are given to us, that is 2, C is 2 and 2.0, and then that is given as delta theta is given as 50. So it means that this is 100 joule. And in 4 number part, 100 joule is C number, kilojoule. That is kilojoule. And C option is the correct option. Now we are turning our focus to question number 5, which is the last question of this section. Then we will turn our focus to section number B. Ladies and gentlemen, 5 number question is saying a 4 kilogram mass of copper. So M is equal to 4 kilogram of specific heat capacity. C is 400 joule per kilogram per Kelvin. Yes, this is specific heat capacity. From the unit we can understand that it is specific heat capacity is heated for 160 seconds. T is equal to 160 seconds. Further, they are saying by a heater of power 100 watt. So power of the heater is 100 watt. Power of the heater is 100 watt. What is the rise in temperature? We have to find delta theta. Is specific heat capacity is 1 over m, and here I am writing PT divide by delta theta. The only thing which is not given is delta theta. All other things are given. So we are writing 4 instead of 400 instead of that C, and instead of M we are writing 4. P is 100 and T is 160, and delta theta we have to find it. We have to find this delta theta. So this, when multiplied with 400, and this is 100 and this, so it will be 16,000 divided by delta theta. Now we can move delta theta to 1600 position and 1600 to delta theta position. So delta theta is equal to 16,000 divided by 1600. So these two zeros will be cancelled with this one, and when we calculate all these things, it will be equal to 10. Yes, so it will be 10 Kelvin. The answer is we are having is 10 Kelvin, and 10 Kelvin is given at A position. So it means that A option is the correct answer of these. Ladies and gentlemen, that's it for the first portion. We are coming towards the section B, which are structure question. Let me erase the whiteboard first and then I will come back. Okay, we are back, and question number 1 in section B is saying we distinguish between the heat capacity C and the specific heat capacity. Let us distinguish between them. First of all, we are writing heat capacity. Heat capacity. The amount of heat required to raise the temperature of an object by 1 Kelvin or 1 degree Celsius. Now specific heat capacity. Specific heat capacity. That is the second part of this question. The amount of heat required to raise the temperature of 1 kilogram of a substance through 1 Kelvin or 1 degree Celsius. Ladies and gentlemen, the distinguished word is 1 kilogram, which cannot be found here. So if 1 kilogram is there, then it means it is a specific heat capacity. If 1 kilogram is not there, it is specific. One thing more that we can distinguish. The unit is joule per Kelvin or joule per degree Celsius. If nothing is said about anything and only the unit is given, then you have to understand that this is a heat capacity. While in this case, joule per kilogram per Kelvin or joule per kilogram per degree Celsius, if the unit, then we will understand that the question is talking about the specific heat capacity. The question is also saying that how are they related with each other. So ladies and gentlemen, specific heat capacity C is Cm. We discussed this, that this is also, so you can write it like this, mc. So if m is constant, so it means we can write c is related to c directly, that is having a direct relation. Specific heat will increase if the heat capacity is more. So they are related with this equation. Okay, now we are turning our focus to question number 2. And question number 2 is saying that an electric kettle is rated at 25 watt. So P is equal to 25 watt. Ladies and gentlemen, rated means that it is written above this, that this much power this heater can generate. So it is rated like this. Okay. Number A part. Calculate the quantity of heat generated in 2 seconds. So SP is equal to Q divided by T, and we have to find Q. So Q is equal to P into T. and P is equal to 25 and T is equal to 2. So that will be equal to 50 joule. Now, ladies and gentlemen, the second part of this question is saying that the rise in temperature of 150 gram. So, means M is equal to 150 gram. We are taking data for the second part of water. If electric kettle is switched on for 5 minutes, T is equal to 5 minutes, means that 5 multiplied by 60, which is equal to 300 seconds. Minutes we have to convert to the standard unit, which is second. And the specific heat capacity is 4 joule per gram. It is given as per gram per degree Celsius. And they are asking us to find delta theta, rise in temperature. So keeping in mind the data in first part and second part, we can write that C, smaller c, is equal to 1 over m p cross t, and that is delta theta. So ladies and gentlemen, we have to put all the values first. C is 4, m is 1 over 50, P is given as 25, and we found Q is equal to 50. Q is equal to PT, so directly we can write 25, and then T is given us in this case 300, and delta theta we have to find. Then we are calculating this with this, so that will be 600, and when we multiply 7,500 delta theta, and delta theta is equal to 7,500 divided by 600. These two zeros will be cancelled, and that will be equal to a degree Celsius. 12.5 degree Celsius is the answer. Now we are turning our focus to question number 3. And question number 3 is saying a 500 watt heater P is equal to 500 watt is totally immersed into a huge block of mass 10 kilogram. So M is equal to 10 kilogram with a temperature of 30 degrees Celsius, and we have to write delta theta is equal to 80 degree Celsius minus 30 degrees Celsius. 80 degree is given in the next scenario. So we will write delta theta is 50 degrees Celsius. Now ladies and gentlemen, let us understand the question. They are saying 10 kilogram with a temperature of 30. The initial temperature is 30. In 6.3 minutes, T 6.3 minutes. So we have to multiply 6.3 with 60. So it will become seconds. And when we multiply this, we will get 6.378 seconds. We will get 378 seconds. Ladies and gentlemen, it will take how much? 6.3 minutes. The temperature of the metal rises to 80. I given this is earlier told you that they given us this 80. So the temperature difference, first it was 30, in 6.3 minutes it rises to 80 degrees Celsius. Calculate the specific heat capacity. Here I am writing that we have to find small c, and small c is again equal to m p cross t r q divided by delta theta. Everything is given. So we have to write m, and that is 10, 1 over 10, and p is 500, and that is 378 T. Here we found it. And delta theta is 50. We found that as well here. So ladies and gentlemen, this 0 will be cancelled with these two zeros, and this 5 will be cancelled with this one. So we will only be left with 378 joule per kilogram per Kelvin, and that will be the final answer. Now we are doing question number 4, but before that I have to make a diagram. So wait for 1 second. In front of you, if I am creating this diagram, it will waste your time. Wait for a second. Okay, we are back and we are doing question number 4 on a spacious location that was very congested area, so I made it here. Okay, ladies and gentlemen, this figure is given and they are saying the arrangement shown in the diagram is used to determine the specific heat capacity of an unknown metal block, which is this one. This is the metal block. It is written here. Uh, the circuit is switched on for a time interval of 5 seconds. So let us write that T is equal to 500 seconds. And the given data is change in temperature, that is delta theta, and that is 50 degrees Celsius. And they given us the mass of the metal block. So M is equal to 1 kilogram. And a meter reading. So I will write the current. Ammeter is a device for measurement of the current. There is another device which is called galvanometer. Galvanometer is used for detection of the current, but ammeter is used to measure the current, and it is given as 5 ampere, and voltage is given as 8 volt. This is voltmeter. It is denoted. So all this data is given to us, and thus using the above data, calculate the specific heat capacity of the unknown metal. We have to find the smaller c. Remember, ladies and gentlemen, we have a formula that is P is equal to IV. We will discuss that formula when we go to electricity portion, which is very interesting. So P is equal to IV and I is 5 and it is so 40 watt is the power. We can find it from here. Then we are saying that M and P cross T, and then we have delta theta. All the data is given, so we are directly putting it 1 divided by 1, because 1 kilogram is the mass. P is equal to 40. T is given as 500 and delta theta is given as 50. Now it is the time to calculate this. So this 0 is cancelled with this, 5 ones are and 5 tens are, and C is equal to 400 joule per kilogram per Kelvin, and that is the ultimate answer of this question. There is a thermometer which is showing the change in temperature. There is a meter which is giving you the change in the current, and voltmeter is giving you the voltage. So all these arrangements are given you this data. Keeping in mind this data, we are using this formula, putting the values and getting the result. Ladies and gentlemen, that's it for today. Tomorrow we will do more questions inside this. We will start from 5, 6, 7 and so on. We will go. There are many questions remaining, so stay tuned for the fun. Thank you very much for watching. Allah Hafiz.